So exercise 4E, question 1. To a man cycling east at 4 meters per second, the velocity of the man is positive I, 4I, plus 0 in the j direction. The wind appears to come from the north. So we come back to the velocity of the wind. We call it xi plus yj. So the velocity of the wind relative to the man, it appears to come from the north, which we'll use now in a minute. So we're going to get our x minus 4, velocity of wind, minus the velocity of the man. Just in case you get it the wrong way around, maybe set it up like this every time. So we have x minus 4 in the I direction and just plus y in the j direction. So what can we say? It's coming from the north. So if it's coming from the north, we can say there's no I. So x minus 4 has to be equal to 0. So x is equal to 4. So that's all for x. So now we use the second part here. To a woman walking south at 1 meters per second. So we'll call it the velocity of the woman. When we'll call her a girl. The velocity of the girl is going to be just south at 1 meters per second. So 0I minus j, or minus 1j. We'll put the 1 in here. So we're going to need it. The same wind appears to come from the northwest. So it's coming from the northwest. It's coming down in this direction on our x and y axis. So what can we say here? X is going to be equal to, if it's coming down this way, x is equal to minus y. So it's the same wind. So the velocity of the wind is xi plus yj. And the velocity of the wind relative to the girl is equal to x in the I direction, or x minus 0, plus y minus 1. So y plus 1 in the j direction. And x is equal to 4. So 4, if it's x equal to minus y, so just double check, coming from the northwest, yeah. So this is equal to x equal to minus this. So 4 is equal to minus y minus 1. Which give y a value of, if we bring it to the left, positive, and minus 4 minus 1 is minus 5. So the velocity of the wind is xi plus yj. We got 4 for x, so 4i minus 5j. And that's meters per second. Okay, the speed and direction of the wind. So the magnitude of the velocity of the wind is the square root of 4 squared plus 5 squared. 36 and 25 is going to give us the square, 16 and 25 is going to give us the square root of 41. It's also meters per second. And the angle, well, the angle, the tan of theta, is going to be my y over my x, which is my 5 over my 4. And the inverse tan of that will give, inverse tan of 5 over 4 gives 51. Is it the nearest degree? No, 51.34 degrees. And it's positive, negative, so we take this as the origin. It's gone 4 minus 5, it's gone down this direction, and theta will be in here. So that's my 51 in there. So it's gone south of east. And we're also asked, if the man were to cycle north at 4 meters per second, from what direction to the nearest degree would the wind appear to blow? Okay, so the velocity of the man is 4 in the north direction, so 0i plus 4j. We have the velocity of the wind. It's 4i minus 5j. So the velocity of the wind relative to the man, not w, v for velocity, is going to be 4 minus 0, so just 4 in the I direction, and it's going to be minus 5 minus 4, which is minus 9 in the j direction. So the angle, direction, the tan of theta is 9 over 4, which will give theta to be the inverse tan of 9/4 is 66 degrees, and it's positive negative, so same as the last one. It appears to be going down in this direction, and that is south of east. Okay, we move on to question 2, so stick it over here. When a man walks due south at 1 meter per second, velocity of the man, he's going due south, he's going this direction, so we have 0 in the I direction and -1 in the J direction. It's the velocity of the man. The velocity of the wind appears to come from the southwest, so the velocity of the wind is equal to xi plus yj. So the velocity of the wind relative to the man is equal to x minus 0, so just xi, and plus y minus -1, y plus 1 in the j direction. And what's that appearing to be? The wind appears to come from the southwest, it's coming from over here, so it's going up in that direction, so x is equal to y in this case. So x is equal to y plus 1. Okay, what else is going on here? When he walks due north at 3 meters per second, so he's going in this direction, so the velocity of the man, he's going due north, so 0y plus 3 meters per second, 3j. The wind appears to come from the northwest, so appearing to come from the northwest, it's appearing to come from over here. It's going down that way, positive negative, so x is equal to -y. So we have the velocity of the wind again is equal to xi plus yj. So the velocity of the wind this time relative to the man is going to be x minus 0, xi, plus y minus 3 times j. And if x is equal to -y, x is equal to -y plus 3. And above we have x is equal to y plus 1. So we can say that y plus 1 from x above has to be equal to -y plus 3, which would give me 2y, bringing the -y to the left. 3 minus 1 is 2, so y is equal to 1. Therefore, if y is 1, you can see from above x is 2. So the velocity of the wind becomes, which was xi plus yj, which is 2i plus j, meters per second, I think, not kilometers an hour in this case, meters per second. So that's what we have for the velocity of the wind.